Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida. So in this section we will be covering the Python coding of SensorWorld using tkinter graphics. So welcome to SensorWorld, which is being developed as the next step up from the AI Classic Grid World, and this is SensorWorld. It's been completed to the point of the agent being able to detect everything, and we'll give that a little run for a few minutes and while I continue talking. So it comes out and now we'll detect everything and put its sensors on only when it's hasn't detected something. So this project will eventually be developed as a deep reinforcement learning algorithm similar to the deep Q-learning types that came out of the DeepMind earlier work. The next step is to define a deep neural network which will work with SensorWorld, and that's what this post is about. It will show you my coding for a 2 hidden layer neural network, which has taken a friggin' lot of work to kind of work out all the backpropagation, partial differential calculus, but it does work. I'm not going to go through the details of that. The code will be put up on my GitHub as always, and you can use it there. There's plenty of labels and explanations in it as far as I can put it. So the code currently runs, and we'll run it in a minute, fairly well, and I've got it up to a reasonable level of being able to return the data value closely approximating its target. So we'll switch this off and we'll get rid of that, and we'll come over to the neural network algorithm. I'm not going to say too much about this other than the fact that there is some plotting stuff up here. This is the data, which is the value data on each of the states in SensorWorld. I have an algorithm which will enable me to get some reasonable weights for this before it starts to run through its training set. Otherwise, you would generally put something down the order of a weight generating algorithm. I'm not going to go into this. It's something you can kind of knock out on your own. These are variously labeled as to what they are, so one can follow the pathway of how the matrix works in terms of its backpropagation. I needed that to kind of work out all the math, which took forever. So this is the forward pass, and once again all of these have been documented such that at least I can understand where I'm coming from and going to. And this is the algorithm for the backpropagation, and then learning to recycle the weights round and the presentation of the data. And this will be up on my GitHub and posted at the bottom of this post. So we'll just run this along, and it comes out reasonably well. So I'm just running it through 200,000 cycles. It's been tuned a little bit by hand to a reasonable level of optimization. Not perfect, but it's reasonably good. And when this is finished running, it'll put out the graphics from the MATLAB, but it's the data that's kind of more important. The two sets of data here are the same because the data is once it's run through the neural network should closely approximate what the target is, and so we can see the data here. It's up to 99.9 really 007. There is that little graphics thing that comes along with this, which we can plonk out here. And the variance is like, there's a little bit here, but this is my first run around. Maybe I can tune it up marginally better. So this is basically the code if you wanted to kind of get into something more complex. This is a good starting point. The code is here. I've used a TANH activation function because I was having trouble with the Relo. Couldn't get it to achieve anything on some form of stuff, so I just didn't want to waste my time on that. But that's generally what is used these days. And you should be able to use this as a springboard for going to deeper neural networks, because once you can code out one, get the forward pass done and the back propagation, then it's just a matter of just progressing to higher levels and getting the training right, such that it gives you the data you want. Now from here on outwards, when I've got this suitably kind of adjusted, we'll be moving back into the sensor world and applying this to the Q-learning algorithm, or trying to find how to do that, because I haven't done that before, but that will be the next step to complete the journey of fulfilling this objective of coding a fully functional running deep reinforcement learning algorithm.